Why do analog filters need capacitors and inductors? Imagine trying to tune a radio to catch your favorite station without static or noise. That's what filters do in electrical signals, helping us pick out the right sounds or signals. Now, how do they do that? Well, it all comes down to special components called capacitors and inductors. These parts are the key players in shaping signals in circuits that process analog signals. Analog filters are circuits that allow certain frequencies to pass while blocking others. They are used in many devices like radios, audio systems, and even in controlling signals in machines. The reason they need capacitors and inductors is because these components react differently depending on the frequency of the signal passing through them. This reaction is called impedance, and it changes with frequency. Capacitors store energy in an electric field and releases it when needed. Their impedance drops as the frequency increases, meaning they let high-frequency signals pass more easily. Inductors, on the other hand, store energy in a magnetic field. Their impedance grows with frequency, so they resist high-frequency signals. This difference allows the circuit to filter out unwanted parts of a signal. In a simple low-pass filter, a capacitor is used to divert high-frequency signals to ground, letting only low frequencies continue. Conversely, in a high-pass filter, the capacitor blocks low frequencies and allows high ones through. Inductors can do the same but in reverse. They block high frequencies in a low-pass filter and pass high frequencies in a high-pass filter. By combining capacitors and inductors, engineers can design more complex filters like bandpass filters that only let a specific range of frequencies through or bandstop filters that block a certain range. These components are also used with operational amplifiers in active filters to get very precise control over the filtering process. In real-world applications, these filters help improve audio clarity, reduce noise in power supplies, and process signals from sensors. When designing these filters, engineers choose the size and value of capacitors and inductors based on the cutoff frequency needed and the type of filter they want to create. So, the reason analog filters need capacitors and inductors is because their impedance changes with frequency. This property allows the circuit to distinguish between different parts of a signal and shape it accordingly. Without these reactive components, it would be impossible to selectively pass or block certain frequencies in analog signal processing and control systems.